Here already I have an array of size 5 that is created in heap, and pointer is pointing to that array. So this is a pointer P, and this is in stack, this is in heap. We know very well now. So this is pointing there. Suppose already it is having some elements. That size 5 is not sufficient for me. I want a larger size array. Then one method for increasing the size is take one more pointer, let us call it as Q, and create a new array of required larger size. Let us say I want an array of size 10. Then pointer Q will be pointing upon an array with a larger size 0, 1, 2, 3, so on. Now this Q is pointing on a larger size array. So I cannot increase the size of the same array. Already I said that. So alternate is create a bigger size array. Now transfer all those elements from P to Q. So we know the size of P very well, that is size is 5. So for I assign 0, I is less than 5, I plus plus. Then in Q of I, copy the elements of P of I. So I am copying them using for loop. So all these values will be copied here, 5, 8, 9, 6, 4. So the values are copied there. And even there is one function in C language that is called as mem copy, that is memory copy. You can use that and mention these two arrays. So those contents will be copied here. So using for loop I am showing them. Next, we want to increase the size of this P. Actually P is a pointer. P is pointing on so and so array now. Now you have to make this P point on this one. But before making P point on that one, let us delete that array. So here say delete P. As I said, if you don't delete unused memory, then it will cause memory leak. Means the shortage of memory, reduction in the size of the memory. So it is unused now, we don't need now. So delete that one. So this memory is deleted. Then make P point on Q. So wherever Q is pointing, P will also point to there. So now new location where P is pointing is this one. Then now this array is pointed by both P as well as Q. Now let us remove Q from there. Q assign null. So Q will no more point on that one. This is null. So this is not pointing on this one. It's pointing on this P. Now if I say P, this is the array now. That array is gone. It is deleted. So it is removed from the memory. And P array size is now 10. Now let us take the example like this. Like the P was pointing on this array. So P is having car. Now P is having a small car. Now that car is not sufficient. P needs a bigger size car. So P purchases a new car. So Q helped in purchasing a new car. Now P was having both the cars at that time. Then all these things are transferred in a new car, and that car is sold out. Now P is owning this car. So for shifting from one car to another car, Q has helped because P has to sell away that car also. Or else you can take the example, this room is not sufficient for conducting a class. The students are growing in number. We need a bigger room. So we cannot increase the size of the current room. So we have to shift to a new bigger room. So this is a new bigger room. And all the students from that class are moved to this class. And there is a lot of free space for more students to sit in the class. So that's the idea followed for increasing the size of an array. So if you are not doing it, if some API is doing it inside programming, then definitely it is following this method because the same size array cannot be grown. Now I'll tell you the reason why the array size cannot be grown, because the memory for the array should be contiguous. For example, the beginning address of this is 500 and 501, then this should be 2, 3, 4, 5, 6, 7, 8, 9, then the next location must be 10, 11. Now we don't know whether that location is freely available or not, or it is used by some other object inside the same program. So there is no guarantee that the next consecutive locations are free or not. If the consecutive locations are not free, then the array cannot be increased. That is the reason we say that array size cannot be increased. So rather than that, we will have another larger array and shift the elements. So this is about static and dynamic array.